So when we started out, we had the cone in class. If you have the cone laying on the ground like this, flat on the ground, if you do a section that's parallel, that's how you get the circle. So when you section the circle right here straight across, that's how you get a circle. To get an ellipse, you're going to section at an angle. And so you can tell when you section this, it's not going to be a circle, it's going to be more oval shaped, is what you see here, which mathematical term is an ellipse. So it's the set of all points such that the sum of distance from two fixed points is constant. The midpoint of the line segments that connects the points is the foci is the center. So there will be a center right here of the ellipse. So let's take a look, and this is one of those where I'm going to give you formulas in a minute, but I'm not going to derive the formula like you did for a circle because it's a little bit more involved. So if you think about it, an ellipse can be shaped, or it can be horizontal, or it can be vertical. So you look at which way is longer. It can be, sort of more long than wide, or more wide than it is long. The points of an ellipse, at the very middle of the ellipse, just like the circle, is a center. Okay? And then if you look at which axis is the longest, we're going to call the major axis. So on the left, you see the major axis is vertical, and over here on the right, you see that the major axis is horizontal. And then these 2 points, a focus, the plural focus is foci. So the foci that you see here, those are the points such that the distance from here to the curve and here to the curve, the sum of those distances is always fixed. Okay. Now, if you have a center and you have a focus, at the edge of where that ellipse is, you will have a vertex. You'll also have a vertex here. So there are 2 vertexes. And then where this shorter axis hits the ellipse, that's a covertex. Okay? So in this one, if it's the vertical, because it's longer vertically, you have a center, a focus, and a vertex, all on here. Center, focus, vertex. And then if you go horizontal, you've got center and covertex. Okay? So these are all the pieces, and they're all going to play a part in how we graph and come up with the equations. Now, that looks quite complicated. The formula is not too complicated. Standard form of the equation of an ellipse centered at hk, x minus h squared over a squared plus y minus k squared over b squared equal 1. Hk is the what? Not vertex. Same as a circle. Hk is the center. So hk is the center. There's a clue here where it says the ellipse that is centered at hk. That's your clue that hk is the center of this ellipse. Now, A, in this case, is going to be, A will be the distance along the horizontal. Okay, so if we look at this, in this particular problem right here, the distance from here to this vertex, that is going to be A. And then the distance from the center to the vertex at the top, that is going to be B. Same thing here. From here to, in this case, is a covertex, that is A. And from this vertex down here, that is B. So wherever you are, if you're at the center, to get to whatever vertex, either a vertex or covertex, horizontally, that distance is A. Vertically, the distance is B. So let's take a little bit more look at the details here. Now this is one of those things, this has all of the details. You're going to drive yourself crazy. You can't spend time memorizing this. You're just going to have to work problems and let this sort of become part of your muscle memory of how to figure out where the pieces are. So a vertical ellipse is when B is greater than A. So B always goes with the Y term. When B is greater than A, you're going to have a vertical ellipse. What happens when A is greater than B? You have a horizontal ellipse if A is greater than B. So let's look at the vertical ellipse. So a vertical ellipse means I'm going to have a center, and then it means that the focus and the vertex are all going to be on this vertical line. So this is my major axis, this is my minor axis. So if this is the center, what's the distance from here to the vertex? What is the center to the vertex? What's that distance? It's in our formula. From the center to this vertex will always be what? B. Okay. From this center to this covertex will be A. So if you look at it, if this is HK, this is H and then K plus B. That's where I get this from. And then over here, the distance from here to here is a. So this is h plus a, k. This is h minus a, k over here. And like I said, this kind of stuff, don't worry about memorizing this. Just acclimate yourself to, like, I know the center is here. Whatever I have here, vertex or covertex, that's A. Whatever I have here, vertex or covertex, that's B. Okay. And then what you've got to figure out is the focus. The distance from the center to the focus, we're going to define that to be C. And C is going to be the absolute value of A squared minus B squared. So the focal length is C, and C squared is the absolute value of A squared minus B squared. Now, if this distance from here to here, what is this distance? Tell me. What is that distance? That's A. How long is the minor axis? 2A. So that's where the minor axis here is 2A. And if this distance from here to here is, what's this distance from here to here? That's B. How long is the major axis? 2B. Okay. So nothing much changes when I go to a horizontal ellipse. So this is the case where A is greater than B. So distance from here all the way to the end, that is A. Okay. The distance from here all the way to this top vertex, what is that? That is B. The difference here is now my focus and my vertex lie on the horizontal line. Okay, so this is still A. This is the point, the distance from here to here is always C. The distance from the center to the focus is C. C is always absolute value of A squared minus B squared. So in this case, which is the major axis, the horizontal or the vertical? Horizontal is the major axis, so it's 2A. Vertical is the minor, it's 2B. Okay. Well, because if the distance from here to here is A, then the distance from here to here is A. Okay. So it has to be 2A, the whole length of the axis. Okay. So the best thing to do is let's just start working some of the problems here, and we'll get going. Okay, so let's look at this. As often as I can, I'm going to write down formulas in this whole unit. X minus h squared over a squared plus y minus k squared over b squared equal 1. That's the equation of an ellipse in standard form. Okay? According to this formula, the center is what? HK. So what is the center in this next one here? In this particular problem, what's the center? 0, 0. Okay, the center here is 0, 0. Because think of this, this is x minus 0 squared over 49 plus y minus 0 squared over 100 equal 1. So this is an ellipse that's centered at 0, 0. Okay? The values of A and B. What's the value of A? A always goes with x. What is A? A is 7. What is B? B is 10. Is this a vertical or horizontal ellipse? It's vertical because B goes with the vertical. B is bigger than A. This is a vertical ellipse. Okay. So that tells me my center and then the focus and the vertex are all going to be on that vertical axis. The co-vertices will be on the minor axis. Okay. So at this point, what I tend to do when I'm doing ellipses is sort of graph what I know at what time. So I know that this is the center. That's the center of this ellipse. Okay. Now I know that A is 7. Okay. So I can just count out 7, and that's right here. And then count -7, which is right here. And then B is what? B is 10. So I can count 10, which is right here and right here. Okay? So we established this is a vertical or horizontal? This is a vertical ellipse. So that means this point is my what? That's a vertex. This is a vertex. What are these 2 points over here? These are co-vertices, yes. Okay. And I know enough to draw this ellipse at this point. I'm not really great at drawing them, but mine look more like almonds than ellipses, but there it is, okay? So that's what this ellipse will look like. Now, let's figure out what else they want. Find the vertices, okay? What are the coordinates of the vertices here? 0, 10, and 0, negative 10. So the vertices are at 0, 10, and 0, negative 10. Where are the co-vertices? Yeah, 7, 0, and negative 7, 0. Now, well, let's do number 8. What's the length of the major axis? Which axis is the major axis? The vertical. So it's what? 2 times, what's the length of it? 20. Yeah, the vertical axis is 20. What's the length of the minor axis? 14. Now, to find the focus points or the foci, you have to use this formula, the focal distance. So C is the distance from the center to the focus. And it's defined, C squared is the absolute value of A squared minus B squared. So C squared is equal to the absolute value. What is A squared? What, 49 minus what? 100. The absolute value, that is what, 51. So C squared equal 51. That means C is equal to the absolute value of 51. Okay. So the distance from the center to the focus is the square root of 51. Do that on a calculator. So that is 7 point something. About 7.1, so just a little bit over 7. So this is about 7.15. Okay. So that means if I'm at the center, which direction will I go to find the focus point? Do I go up or down? I mean up or, not up or down. Do I go up or do I go left or right? Do I go up or down or left or right? Where do I go to find the focus? Up, because it's a vertical ellipse. So this is somewhere right in here is a focus point. So 7 point something. And somewhere here, 7 point something is another focus point. Okay. So what are these points? This is the point, what? 0, and what's the distance from here to here? Yeah, the square root of 51, okay? So that focus, the focus points are going to be 0, square root of 51, and what's the other one? Yeah, negative square root of 51. Those are the two focus points for the ellipse, okay? Now, this is why we've been working all year. We did parabolas to build up. This is a lot of detail, okay? So I'm not going to say it's easy, but if you know, everything sort of runs together. You just got to be very solid on what A is. A is the vertical, the horizontal. B is for vertical. C squared, absolute value of A squared minus B squared is the focal length. Knowing what's the major axis, what's the minor axis, okay? Let's take a look at another one, okay? As often as I can, what is the formula for ellipse? It's what? X minus what? X minus H squared over A squared plus Y minus K squared over B squared equal 1. Okay? So that's the equation of the ellipse centered at HK. Where's the center of this ellipse? Yeah, 3, 9 is the center of this ellipse. What's the value of A? A is 7. B is 2. Is this horizontal or vertical? This is horizontal because the A that goes with the X is larger than the B, which goes with the Y. So it's a horizontal ellipse. So it means the horizontal axis will be my what? Major. The vertical will be the minor. So on the horizontal axis, I'll have a center, focus, and vertices are all going to be there. So let's go ahead and graph what we know. The center is 3, 9. So 1, 2, 3, 9, which is somewhere right here. Okay. So there is 3, 9. Now, A is 7. So that corresponds to what? A equals 7. What does that mean? From the center, I go what? 7 right and 7 left to find the vertices. So at 3, what's 3 plus 7? 10. So if I come over to here, okay, there's going to be one vertex. And what's 3 minus 7? -4. So that puts me right here. So here's the center, there's a vertex, and there's a vertex, okay? So I have the center and the two vertices. Now, B is equal to 2. What does that tell me? How do I use that information? To go which way? Pardon me? How did I get the vertices? So if the center is 3, 9, A is 7. So if I go over to the right, 7, okay, that's the point, 10, 9, okay? And if I go to the left by 7, that's how I get the vertices. Now to find the co-vertices, I'm going to go up 2. So right here is a co-vertex, and then right here is another co-vertex. So if you look at this ellipse, something like this. Okay. So what are these vertices points? This point is what, 10, 9 is one vertex. What's the other one? Yeah, -4, 9. Co-vertices. All right, 2, and then what? I'm hearing mumbling. 2 what? Okay, what did I do to get to the co-vertex? How far up did I go? 2. So what happens when I add 2 to that number? 2, 11. What's the other one? 2, 7. Okay. Oh, it's 3. Sorry about that. So let's back up. That's 3, 9, right? And 3, 7. Okay. Okay, back up. 3. Let's see. This was at 3, 9, so it's 3, 7, and 3, 11. Sorry about that. Like I said, there are lots of mistakes that can be made on this. So 3, 11. So from 3, 9, you went up 2 and down 2. So 3, 11, 3, 7. Okay, you guys got it? Now, to find the foci, you need to find the focal length. The definition of the focal length is the distance from the center to the focus. Okay, we have a formula. What's our formula for focal length? Yeah, c squared is the absolute value of a squared minus b squared. So in this case, c squared is the absolute value. What is a squared? Yeah, so 49 minus 4. 49 minus 4 is 45. So c is the square root of 45. You learned how to simplify that last semester. That is 3 times the square root of 5. So on my calculator, what is 3 times the square root of 5? About 6.7. So this is about 6.7. Okay, so it means somewhere about 6.7 away is where I'm going to find a focus point. So if that's 7 away, so it's going to be pretty close right here. So there are going to be 2 focal points right there. So to find these points, what is this coordinate of this point? I was at the center, but how far? So here, to find the x-coordinate, here's the center. What's the distance from here to here? What is it? We figured it out. It's square root of 45, 3 times the square root of 5. Okay, so this point right here is going to be what? Where am I right here? 3? So it's going to be 3 plus what? I'm not going to write 6.7, okay? I'm going to write it exactly, okay? And then what's the y coordinate there? 9. So that's one focus, okay? What's the other one? 3 minus 3 square root of 5, 9, okay? I mean, the other way you could write this is 3 plus the square root of 45, 9, and 3 minus the square root of 45, 9. Okay? Don't get bent out of shape that those aren't nice little integers, okay? It's just, that's what it is. 3 plus 3 root 5 is the distance there. What's the length of the major axis? Yeah, so the major axis is 14. The minor is what? 4. Okay, so 14 and 4. Okay. So what's hard? What's challenging about this? Yeah, I mean, you got to be very solid with your definitions, knowing that the A goes with horizontal, B with the vertical. Know the definition of focal length. Know that sometimes your vertices are vertical, sometimes they're horizontal. Okay. So I think we do have another example to work. So this is the summary of what we did. Know the equation. Okay. When you see the equation, the easiest thing in the world is to figure out the center. It's HK. Okay. Then you take the square root of these numbers to figure out what A and B is. A will be the distance from the center to whatever you have horizontally, if it's a vertex or co-vertex, okay? B will be the vertical distance from the center to whatever you have at the edge, either a vertex or a co-vertex, okay? And the focal length is C squared, the absolute value of A squared minus B squared, okay? So if it's a horizontal ellipse means that it's stretched out this way. On that horizontal line, you're going to have a center, 2 foci, and 2 vertices. On the vertical, you'll have co-vertices. If it's a vertical ellipse that's stretched longer than it is thin, on this vertical line, you'll have a center, 2 foci, and 2 vertices. And on the horizontal, you'll have what? The co-vertices, okay? So you got to get solid with that. Let's see, I think I have one more to work, and then we can turn you loose for the homework. Okay, as often as I can, I'm going to write down this formula because I don't want to get it confused with what I learned about circles. There we go. So where's the center of this ellipse? Yeah, 0, -2. What is A? 6. What is B? 7. Is this horizontal or vertical? This is vertical because B is greater than A. B always goes with my y value. So this is a vertical ellipse. So I can graph 0, -2. That's right here. Okay. And since B is 7, how will I use that information? I go up 7. 1, 2, 3, 4, 5, 6, 7. And what is that point? That is a what? That is a vertex. Okay. And then if I go down 7, 1, 2, 3, 4, 5, 6, 7, that is another vertex. Okay, so now I know the vertices. The vertices are what? 0, 5, and 0, -9. All right, so just check it. -2 plus 7, no, it's -9. So -2 plus 7 is 5. -2 minus 7 is -9. Okay, in this graph, the 10 is actually right here. Okay. So I've got the vertices. Now, how do I find the co-vertices? What is A? A is 6. So it means that if I go over 6 right here and go over 6 here, those are going to be co-vertices. So what are those points? It looks like -6, -2, and then what? 6, -2. Those are the co-vertices. So at this point, I know enough to graph it. So I mean, it's already. The only thing left to find would be the foci. So focal length, c squared, equal absolute value of a squared minus b squared. So that is what, 36 minus 49. So this is 13. So the focal length c is equal to the square root of 13. Okay. So by definition, what is c? C is the distance from where to where? From the center to the, what do we call c? C is the what? The focal length. That means it's the distance from the center to the focus, okay? So c is the distance from the center to the focus. Where are the focus going to be? Where the foci? Where would they be on this one? Would they go, will I go up or down or left or right? Yeah, it's going to be up or down. So c is going to tell me where this focal point is. So the square root of 13, anybody know that is what, 3 point something? You know, so it tells me that if I go up 1, 2, 3 and some kind of fraction, 1, 2, 3 and some kind of fraction, those are going to be the two foci. Okay. Now, what are those points? How do I get to this point? Okay. What's the x coordinate of that point? If I'm trying to get from here to here, how far over to x do I have to go? Nowhere. Okay. Now, how do I tell you how to get to this point? I go up how much? Square root of 13 from where? From the center. So this is 0, -2 plus square root of 13. That is one of the focus points. Okay. So it's 0 and -2 plus root 13. That gets me to the first focus. What's the next one? 0 and -2 minus root 13. That's the next focus point. Okay. What's the length of the major axis? The length of the major, 14, and the length of the minor is 12. And there we go. And that is it. So guys, here's the deal. You know, there are a lot of different pieces to this. Okay. You just have to be very solid on the formula, what each piece is. Don't get confused about what horizontal and vertical. A always goes with the horizontal. B goes with the vertical. If A is greater, it's a horizontal. If B is greater, it's a vertical. Wherever your major axis is, that's where you'll find what lies on a major axis. Tell me every point that lies there. The vertex, center, and foci. How many focus points are there? 2. How many vertices? How many centers? 1. What lies on the minor axis? And one other thing. Center. The center and the co-vertices also lie on the minor axis, okay? And then what's the definition of C, focal length? It's the distance from the center to the focus, okay? So that helps you find that point, okay? And then by definition, A is the distance from the center to where? Whatever you have horizontally. You're either going to have a vertex or co-vertex. A is the distance from the center to whatever that point is. B is the distance from what? The center to whatever you have vertically, either a vertex or a co-vertex, okay? And then we are good to go there. Okay.